Stan, and we're going to go over the work, power, and energy test so that if you're taking the retest, you can kind of see what the answer should have been, and you'll get a chance to take a similar test and make up to a 70. All right, so question number 1 talked about this roller coaster right here, and so the student builds a roller coaster track as shown above, where they release a marble from point A. However, the marble doesn't make it through the entire track. What adjustment could the student make in order to make the marble make it through the track? Consider the track to be frictionless. All right, so without friction, the marble is going to keep all of its energy, so its total energy is not going to change. And at point A, it's going to have all gravitational energy, and it's not going to have any other type of energy because it hasn't started moving yet. And so the total energy that the marble has is just enough to get it back to the same height as point A, so maybe about right here. Then it's going to stop. It's going to run out of energy, so it's not going to make it over the hill where point C is. So the only way to fix that would be to move point A higher than point C. Okay, so that was the answer. Raise the beginning of the track, point A, to a higher position than C. Okay, and then the next question, identical twins race up the stairs. Twin A takes 10 seconds to reach the top of the stairs. Twin B takes 5 seconds. Which one's more powerful? Okay, so power means that is a measure of how fast work is done, right? Or how fast energy is transferred. And twin A and twin B would have done the same amount of work to reach the top of the stairs, but twin B did it in half the time. So twin B is more powerful, and the reason they're more powerful is they transferred energy more quickly. Okay, next one. A marble initially compresses a spring at point A.
Miss Mosby,
sorry about this.
Call 5400. Miss Mosby, call 5400.
Anyways, a marble compresses a string at point A, and then it's released. The marble moves through a frictionless track as shown below and has just enough energy to make it to point E. So it's going to get up to point E, but it's not going to have any energy, any kinetic energy at least, left to go any further. Right, so at A, the spring is compressed, so it would be elastic energy. It's not moving yet when the spring is compressed, so there's no kinetic, and it's on the ground, so there's no gravitational. So this option right here, what you're looking for, it has US all the way to the top. At point B, C, and D, right, it's going to go B through the loop, then C, then D. It's going to have a combination of both gravitational and kinetic energy. Now, the higher up it is, the more gravitational energy it has, and the less kinetic. And the further down it is, the more kinetic and the less gravitational. So we're going to kind of rank these in order of highest to lowest. The highest one would have the most kinetic, but they all should have both. So you can see C was the highest. So here was an option for mostly gravitational with a little bit of kinetic. The next was B. So B has 2 bars of gravitational, whereas D only has 1 bar. So D was the one that had the most kinetic and least gravitational, which is what you'd expect. Okay, and then at E, it's going to lose its kinetic energy. And so when it gets to the top, it's only going to have gravitational energy. So let's find the response for that, and that would be here, where it's all gravity and no, all gravity and no kinetic. Let me see if it'll let me put it there. Okay, so match the appropriate conservation energy statement with the point below. All right, the total energy should all be equal to each other, so this one will go first. Okay, and that'll be true throughout this test. Next, we're going to have to match the type of energies we have with what it has here. So it starts with A and goes to, on the right, and goes to E. You see point A is all elastic. Point E, it's all gravitational, so you should have US on the left side and UG on the right side, and everything in between will be both gravitational and kinetic. So let's see if we can find one like that. So you see US A right there. So that's saying that it has all elastic on at point A and has all gravity on point B. So this would be our choice right here. Okay, next question. Two twins race up the stairs. Twin A reaches the top of the stairs in 10 seconds. Twin B reaches the top in 5 seconds. Which twin, if either, did more work? Okay, so with work, time doesn't matter. It just matters how much energy was transferred. So it would have taken, both twins would have used the same force to climb the stairs because they're twins, we're assuming they're the same weight. And they're climbing the same stairs. So they would have equal work. So equal amount of work. Was the work done positive or negative? So they use their own, internal chemical energy in their body to push them up the stairs, which gave them more gravitational energy. So they increased their mechanical energy, which means it was positive work. Yeah, and the reason is they ended up with more energy than they started with, or at least more mechanical energy. Obviously, that energy had to come from within them, but they had more mechanical energy at the end. Okay, so just like the Popper lab where you had the toy that's pushed down on a spring, it popped up. It was moving up at B. At C, it comes to a stop. Then, of course, it's going to go back down after that. So point A, you see height is 0, velocity is 0. So that means we have no kinetic and no gravitational energy. Only elastic. So we're going to choose the one that has only elastic here. Goes there. Okay, at B, it's going to be a combination of kinetic, because it's moving, and gravitational, because it's above the ground. So it should have both. Right, so we want one with U, G, and K. That would be this one. Okay, next at point C, it's reached its highest point, and we know that because it says right here that V for velocity is equal to 0. So it's at that point where it kind of pauses momentarily and it's about to come down. That'd be all gravitational. Goes there. Okay, conservation of energy statements. The first line just says that all the total energies are equal. Okay, the second line should say that the elastic energy at A equals the gravitational energy at C, and in between B would be both kinetic and gravitational. So let's see if we have an option like that. Okay, US for A, and then UG plus K, so that works. Yeah, this one works right here. All right. Let me see if I can just put it in that box. Sometimes it's the hardest part, okay? So this answer here was not the correct answer because it did not have any gravitational energy for B. And you can see right here that B is already above the ground, so it should have some gravitational. The correct answer was the one that had both UG and K at point B, and that's where we chose that one. Okay, match the correct energy graph to the roller coaster. Okay, so here, A has a spring, so it's going to be like the previous example where it's all elastic energy at first. Let's see, find that example. There's the answer choice right there. It's all elastic and no kinetic or gravitational. Okay, then it's going to go through the loop at B. Now B, it's at the highest point, but notice from these little lines below it that it is still moving. Matter of fact, if it stopped moving, it would just fall. And so it needs to have both gravitational and kinetic at point B, right? But at point C, it's also going to have gravitational energy because it's above the ground, and it has kinetic energy. The difference between B and C is that because B is higher up, it's going to have more gravitational energy and less kinetic than C will. So let's find two options here. So B has more gravitational than kinetic, so I'll choose this one for B. And then C would have less gravitational than B does, so this is a good option right here. Okay. Okay, a bowling ball and a feather are both held from the top of the same building. Which object has more energy? Okay, so I know we in the earlier units, we talked about the bowling ball and the feather falling at the same time, right? And that's true. However, the bowling ball has more mass. So once that bowling ball starts moving the same speed as a feather, right, in a vacuum, it would have more energy because it has more mass. So even though their speeds in the absence of air resistance, their speeds would be the same, the bowling ball would still have more mass because it has more energy because it has more mass. So the bowling ball would be the answer, correct answer here. Okay, and then the final question, you see at point A, the skater has gravitational energy. At B, all that gravitational energy has been turned to kinetic, so there should be no gravitational at all. It's just all kinetic. So let's find those here. So all gravity would go here at A, and then all kinetic is option right here. Sorry. Okay, and then at point C, it's going to be some gravitational and some kinetic. He's definitely not near the bottom, so it won't be that one. It'll be this one right here. Okay, and then your total energy at each of the points should be the same. Okay, there's talks about no friction on the track. Okay, so at point A, it'd be gravitational, so you should have UGA, and then point B, it'd be kinetic, and at C, it's going to be both. So let's see if we have, and that would be this option right here. Okay, so KA equals UGA equals KC equals UGC. All right, so go ahead and watch it over again if you need to, but make sure you understand this and you can take the retest again, and good luck.